Welcome to lesson 1.1, the key features of functions. So first let's talk about what is a function. If you remember, a function is a relation where for every x value there is only one y value. Okay, so if we think about a graph, I give you the graph of a line. Okay, here's my line. Okay, so all along, or this is the x-axis, there are different x values all along this line, where for every x value it has a different y value. Okay, that makes this line a function. We could also have other types of graphs, like a parabola, for instance. A parabola that opens upward or downward. Okay, all along here, again, this graph keeps on going from left to right. And for every x value, there's a different y value. So it makes this parabola a function. If I have a parabola that opens to the left or to the right, it is not a function, because you can see right here, for instance, I have the same x value with two different y values. So this is not a function. Okay. So that's the difference between something being a function versus not a function. Function notation. Hopefully you have seen this before. Function notation looks like this: f of x. Okay, it could also be a p of x or an h of x. What's important is this letter is the name of the function. And that's why we use function notation, so that we can give a polynomial or a function a name and refer to it by its name, rather than having to say all the terms of the function. So for instance, if I have f of x equal to x squared plus 3x plus 1, and I have some function g of x, and let's say this is x cubed minus 2x. Once they have names, I can call this one f, I can call this one g, and I can just refer to them that way. So if I wanted you to do some operations, this is something we'll do later in the course, I could say take f and g and add them together. I don't have to say all the terms of the polynomial or the function. Okay, understanding domain and range. So domain, I want you to think of it as the values that you can plug into the function, which are our x values. We could think of them as inputs. When we look at a graph, we describe the domain by the x values, okay, that's important, from left to right. So I highlighted these things and made them a little larger, because that's an important thing to keep in mind, is that we always describe domain by x values, and the order always goes from left to right, or least to greatest. So what you want to do if you're looking at a graph is look at where the graph starts from the left and where it ends to the right. Now keep in mind that that graph may continue on forever in either direction. So if we go back to the previous page, this parabola I drew here, that keeps on going, right? Kind of looks like it's going up steeply, but it does continue going on to the left. It continues on going to the right. For the range, those are the values that come out of the function, the y values. They're the outputs of the function. So when we look at the graph, we describe the range by the y values. And we're looking from the bottom of the graph up to the top. So what you want to do if you're looking at the graph is look for the lowest point on the graph and the highest point on the graph. And again, keep in mind that could keep on going on forever in either direction. So again, if we go back to here, this line, right, this line keeps on going. It keeps on going from left to right, and it keeps on going from the bottom on up. An important note that I want to make is we're going to be describing a lot of different types of intervals in this section. The only time that we use y values is in this case here where we're describing the range. So keep that in mind. All of the other intervals that we describe will be described by x values. Okay, so again, it's only range where we use y values. So let's look at some problems where we're asked to describe the domain and range. So here we have the function x squared minus 3. X squared minus 3 is the graph of a parabola. So if we start with domain, remember what we talked about on the previous slide, you want to go from left to right. Where is my furthest point to the left on the graph? Well, just like the other parabola that I drew, this is going to keep on going. It's going to keep on going to the left, it's going to keep on going to the right. So there are no limits. It doesn't end anywhere along those x values. So when that's the case, for set builder notation, we can say that it's all real numbers. Now, this is the important new type of notation. Okay, we're going to use this a lot, interval notation. Interval notation, all real numbers, looks like this. Negative infinity to positive infinity. Okay, that's that infinity symbol, which is really like a, kind of like a number 8 on its side. Okay. Because again, it doesn't stop. There's no minimum value for the x, there's no maximum value for the x. So we describe it by negative infinity to positive infinity. And we use parentheses, okay, for that interval. Now for the range, range is again described by y values. So I'm looking from the bottom of the graph up to the top. Here's that lowest point on the graph. If I look at my y-axis, that lowest point is a 3. If I look for the highest point, again, there is no highest point because it keeps on going. So it's going to go up to infinity. So for set builder notation, or usually it's just called set notation, we would say that y is greater than or equal to negative 3. What that looks like in interval notation, and again, this is the one that you want to get used to the most because we're going to use it all the time. We rarely use inequalities. We start with a cornered bracket because this time we're including that negative 3. It goes on to infinity, and then we use a parenthesis. So these two, they mean the same exact thing. Y is greater than or equal to negative 3. This means that the range goes from negative 3 to infinity. So it's just a new type of notation that you need to get used to. So on the next page, I put some more examples so that you can see the difference. Notice here we have both cornered brackets. This means the interval goes from 3 to 4, and we're including those numbers. So in set notation, we use the less than equal to symbol. Okay, so 3 is less than or equal to x, which is less than or equal to 4. That's how you would write this out. Okay, remember this bar means such that. So the proper way to read this is x such that 3 is less than or equal to x, which is less than or equal to 4. Here the difference is we have a parenthesis. So notice how this symbol changed to strictly less than. Still less than or equal to on this side because we have the cornered bracket here. So corner bracket means we're including the number, parenthesis means we're not including the number. So you can look at the other examples. Okay, again, when you have infinity, notice that we always use a parenthesis. So what this means we're starting at 3 and we're going on up to infinity. So this is the same as saying that x is greater than or equal to 3, or that 3 is less than or equal to x, which is less than infinity. If you're saying all real numbers, notice it's negative infinity to infinity like we wrote before. Again, parentheses around both. if you have the case where we're going from negative infinity on up to a number, then again, you start with parentheses, negative infinity on up to 3. Okay, so in set builder notation, it would look like this. We never include infinity, we never include negative infinity. Okay, they aren't numbers, so we can't include them. So x is greater than negative infinity, and it's less than or equal to 3. Again, notice with the less than equal to, that's when it's the cornered bracket. Okay, on to example 2. X and Y intercepts. So x and Y intercepts, those are the points where the graph touches either axis, right? There's our Y intercept, here's our X intercept. So a car starts a journey with a full tank of gas. The equation, Y equals 16 minus 0.05x, relates the number of gallons of gas, which is Y, left in the tank to the number of miles the car has traveled, which is x. What are the x and y intercepts of the graph of this equation, and what do they represent about the situation? So you might want to pause the video and think about that for a minute, and then come back. Okay, so the y-intercept is 16, right? So we could write that as 0, 16. The x-intercept is 320, so that's 320, 0. So what do they represent? The 16 represents the amount of gas, right, remaining in the tank. When x is 0, that means they haven't traveled anywhere yet. So that's the starting amount of gas. That's the 16 gallons of gas that's in the tank. The 320, that's the different distance traveled in miles. Okay, so given these values, you could actually figure out the gas mileage, right, which people often like to do, figure out how many miles are they getting to the gallon. Okay, so think about that, how you would calculate that. That wasn't part of the question, but it's a good thing to think about. Okay, miles per gallon. Okay, so what are the x and y intercepts of this graph? So when I look at this graph, okay, and you could plug this into your calculator, okay, or if you don't have a graphing calculator, you could use the Desmos app, or the Desmos on the computer, or Desmos on your phone. You go to the website and you can use the graphing calculator there. You don't have to sign up for anything. Okay, so if it's absolute value of x minus 3, the graph has a V shape. So here's our y-intercept. Okay, and notice when it's a y-intercept, the x value is always 0. So this is 0, -3. And that makes sense, because if I plug 0 into this equation, I get 0 minus 3, which is -3. Here are my two x-intercepts. Okay, so let's see where they come from. If I let y equal 0, then I get this equation. If I move the 3 to the other side, let me move that over to here, I get 3 is equal to the absolute value of x. Now if you remember, when you're solving an absolute value equation, you actually have two answers. If the absolute value of x is equal to 3, x can equal 3, or x can equal -3. Because either way, when I plug that value in, absolute value means the distance from 0, right? And both of these have a distance from 0 of 3. So here's my two values, -3, 0, and 3, 0. Okay, this is our last example for part 1. We're going to identify the positive and negative intervals of this graph. So for what intervals is f of x positive? So what we mean by that, positive means above the y-axis. Right? For a function to be positive, it means that the y values are positive. Function values are y values. So my graph is positive here and here. And where is it negative? Negative means below the y-axis. Oh, I'm sorry. I'm saying y. It should be x. Good grief. X-axis, not y-axis. For some reason I have y stuck in my head. Okay, so again, let me recap that. Where the graph is above the x-axis is where it's positive, and where it's below, did I say y again? Oh my gosh. Where the graph is above the x-axis is where it's positive, and where it's below the x-axis is where it's negative. Now here again, these intervals are described by x values. We're talking about what happens from left to right with the graph. Okay, so let me take these things out for a second. So really what I'm looking at here, I want to start again and see, do I have a minimum value to the left for the x's? And I don't, right? Because remember we've talked about this before. The parabola keeps on going. It's going to keep on shooting over to the left. So there is no starting point, if you want to think of it that way, for this graph. And there's no ending point on the other side. Okay? So that interval, what do you think it's going to start with from what we've done already? If you said negative infinity, you're correct. Okay? So we're going to list out these intervals. Let's start with the positive intervals. So I'm starting from here, way over here, and I'm going in the direction to the right. This is where the change occurs, okay, at -3. So it's positive from negative infinity over to -3. Again, I'm describing by x values. It's also positive from +3 on over. Okay, so the graph's going upward. Don't confuse upward with y values. We're doing x values. So it's at 3. On over to the right, it just keeps on going up. So it's just going to always be positive on this side of 3. Okay, now in between those values, that's where the graph dips down below the x-axis. So it is negative from -3 to 3. Now these are intervals, so for intervals of positive and negative values, you don't have to use ever cornered brackets. Okay, we always use parentheses around these types of intervals. Okay. All right, so that finishes the first part of this lesson. If you need to, you can always go back and review any parts of the video. Okay, and I will see you in class. If you have any questions between now and then, you can send me an email or meet me during the office hours, the Zoom session office hours. Have a good day.